Real quick, I'm going to run you through an analysis of variance, or ANOVA test, which is the proper procedure to run if you are examining the relationship between two variables: your independent variable, which is categorical and has more than two values, and your dependent variable, which is continuous or interval ratio. So click on Analyze, Compare Means, One-Way ANOVA. You can also perform this procedure through the general linear model and univariate dialog box, but this is a simpler way to do it. So since we're only identifying or examining the relationship between two variables, this is the way to go. So click on One-Way ANOVA. I already have two variables set up here. We have our dependent list or dependent variable, which is self-reported delinquency, and our factor or grouping variable, which is rules of the parents. Now I need to select post hoc tests in the event that my ANOVA test is statistically significant. I'm then going to want to further investigate to see which values on my grouping variable are accounting for the bulk of the relationship I may have identified. So I'll click on post hoc. Under equal variances assumed, which means if your Levene test for the equality of variances p-value is greater than 0.05, we're going to select chef in the event that our ANOVA is statistically significant and the size of our groups are not equal. And we're going to select Tukey for the same situation but with equal group sizes. Under the equal variance is not assumed, we could either pick Tam-Haines or Dunnett C. I will pick Tam-Haines T2 and select the significant level of 0.05, continue. In the options dialog box, I want descriptives, homogeneity of variance tests, Brown, Forsyth, or whatever, Welsh, and a means plot. I'll hit continue. I'll hit OK, and that will produce my first output here. Let me make this a little easier to read. Okay, so first up, we have the descriptives for the variables grouped accordingly. Our sample sizes, or the size of our groups, is different: 70, 236, and 64. Their means are also different, ranges from 9.39 to 12.27. Standard deviations, as you can see there. So it does look like there is somewhat of a relationship. Slack parenting styles seem to produce more self-reported delinquency, and rigid seem to produce the least. But let's investigate further to see if this is more variation than can be expected from sampling variation alone. First thing we're going to do is investigate or read and interpret our test for the homogeneity of variances. Our Levene test statistic is 2.557, and the p-value is 0.079. So 0.079, we fail to reject the null hypothesis that the variances are in fact equal, and we will proceed under the assumption that they are equal, therefore. So now we're going to interpret our ANOVA test. Had we rejected the null hypothesis within the test for the homogeneity of variances that the variances are equal, had we rejected this, had the p-value been less than 0.079, we would have then read the Welsh and Brown Forsyth. But variances are equal, so our F statistic for our ANOVA test is 3.967, and it is statistically significant at 0.020. So that means that the groups that we have, the three groups, rigid, average, and slack parenting styles, don't have the same mean for self-reported delinquency. There is a statistically significant difference here. Now the question is that difference existing between all of these three values, or only between two of these three values? If so, which two? For that, we will turn to interpret our, let's see, in this case it would be chef. I'll scroll down some more here. Yes, here we are, the chef post hoc analysis. As you can see, there is a statistically significant difference between rigid and slack. And that is it. Wasn't that something? Okay, so yeah, that's it. And so between average and rigid, there is no statistically significant difference. So if I scroll down further, we can identify or look at the comparison of means chart, which might visually give us the same idea. Okay, so here we are. Basically, the difference between rigid and slack is statistically significant. The difference between average and rigid and average and slack, if I'm reading this properly, is not statistically significant when interpreting the chef post hoc numbers. I will now try to quickly run another test to see if we can interpret a different. Let's see, I'm going to move that over and I'll use variable 38. 58. Which is number of convictions. Same test, let's run it. see what's up with this relationship, I will scroll down past my comparison of means plot. Here we have, again, on our three groups, rigid, average, slack, approximately the same sizes per group. There is, again, quite a relationship, it appears, going on between the mean, in this case number of convictions, and the group. It's important to remember, however, that I have not recoded my dependent variable in this case, so these means are actually one higher than they should be because of a miscoding that's going on. SPSS thinks 0 is 1. I can't really get into that right now, but what I can tell you is that the test for the homogeneity of variances in this case is statistically significant, so we reject the hypothesis that the variances are equal, and we proceed to read the Welch and Brown-Forsyth test statistic and p-values. They are 0.01 and 0.007 respectively. That is a statistically significant value, less than our alpha level of 0.05. So we reject the null hypothesis that the three groups are equal on the dependent variable. Now we're going to go interpret our post hoc analysis to find out where those differences are. In the Tamhane, which is the appropriate one for Welch and Brown-Forsyth, we see that the statistically significant difference exists between average and slack. If we scroll down further and look at our comparisons of mean plot, we see again that rigid to average is not a big enough difference. Indeed, rigid to slack is not a big enough difference, but average to slack is a big enough difference to account for the statistical significant result.